Hi, good morning. Today I'm going to teach about the free body diagram. Now, the free body diagram shows forces. It shows forces acting on one object or one body. Now, for free body diagram, we only draw one object and all the forces acting on it. Now, for example, if we have a box resting on a table. Now, say if we want to draw the free body diagram of this box here, right? This box on the table. Now, we are only interested in the box. So we draw the box alone. And we will show all the forces acting on the box. Now, what are the forces acting on the box? Now, there will be a gravitational attraction vertically downwards by the planet Earth, and we call this the gravitational attraction force by the planet on the box, or we simply call it the weight. Now, this is not the only force that is acting on the box. Now, there will be one more force acting on the box because the box is in equilibrium. It's not flying up, it's not sinking down. The other force that is acting on the box will be the contact force by the table on the box. So if the box is pushing the table should be pushing back at the box. And this force is what we call the normal contact force by the table on the box. Now let's take a closer look at what is a free body diagram. So this is a free body diagram that shows all the forces acting on the box. Now let's proceed to another situation where the box is being pulled to one side along the surface of the table. So suppose if this box is initially resting on the table and is being pulled by a force of say 50 Newton, and it accelerates to the right hand side. Now, if we are interested in all the forces acting on the box, then we will draw the box and only the box. So now, for this free body diagram of the box, there are four forces acting on the box. First, of course, is the 50 Newton pulling it to the right. Now, if it's enough to overcome the friction, it will accelerate to the right. Now, friction always opposes motion. It tries to go to the right, and therefore the frictional force will be to the left. And this is what we call the friction. If the 50 Newton is equal to the friction, it will either be stationary or moving to the right with constant speed in the straight line. If the 50 Newton is more than the friction, you will accelerate to the right. Now, in this case, there are two more forces acting on the box. Compare it to just now, right? The weight is still existing, although it's moving to the right. So there should be a weight and an upward normal contact force by the table on the box. Now, in summary, a free body diagram shows all the forces acting on one object, right? So this is an example of the box resting on the table the weight by the attraction, gravitational attraction by the planet, the normal contact force by the table on the box. On top of the two forces, there is a pulling force to the right in this example and the friction opposing it. So this is a free body diagram. Thank you very much.